Hello, and welcome to episode 5 of the Kalopa Mission Control Podcast. I am your host, and it is a profound pleasure to have you join me once again. Whether you are listening by a fireside with the rain lashing against the window pane, or perhaps walking along a quiet stretch of coastline with the scent of salt in the air, I invite you to take a breath and settle in. Here, we step away from the clamour of the modern world and turn our attention to the vast, rhythmic and enduring pulse of our blue planet. Today, we have a rather special journey ahead of us. We will begin by looking at the magnificent, ever-changing tapestry of the global ocean, exploring some deeply encouraging and sometimes challenging developments in marine conservation. Then we will turn our gaze to the intersection of maritime history and modern engineering, exploring the remarkable world of autonomous robotic sailing. Let us begin with the macro, the great interconnected global ocean. For those of us who have spent our lives studying the sea, the concept of borders has always felt rather artificial. The ocean recognizes no sovereign lines. Its currents circulate freely and its inhabitants undertake migrations that span entire hemispheres. Yet, for decades, nearly 2/3 of the world's oceans, the high seas, have existed in a state of legal ambiguity. They were, in many ways, an unregulated frontier. The High Seas Treaty is the vital mechanism we need to achieve the global 30 by 30 target, the ambitious goal to protect 30% of the world's oceans by the year 2030. It gives humanity the power to establish marine protected areas, or MPAs, in the deep ocean, ensuring that the incredible biodiversity of the high seas is treated as the common heritage of humankind, rather than as an endless resource for the taking. But of course, drawing a line on a map is only the beginning of the story. The true measure of conservation lies in how we manage the delicate, complex relationships within those protected waters. And when we think of where to protect, we must remember that the ocean is not merely a surface. It is a profoundly three-dimensional realm. Recent research from New Zealand has illuminated the hidden wonders of the mesophotic zone, the middle light region of the ocean, typically found between 30 and 150 meters deep. Scientists surveying sponge communities off the Poor Knights Islands discovered something quite remarkable. For years, it was assumed that deep reefs were simply extensions of shallow reefs and could act as a sort of refuge, reseeding the shallows after a disturbance like a marine heatwave. But the data tells a different story. The researchers found that less than a third of the sponge species were capable of living in both shallow and deep waters. Most were highly specialized to their specific depth. This means that biodiversity does not simply stop at 30 meters, nor do the deep reefs serve as a universal backup for the shallows. They are entirely distinct, exquisitely adapted ecological communities. If our marine protected areas only safeguard the accessible sunlit shallows, we leave a vast silent world of deep sea biodiversity completely exposed to human impact. All of this brings us to a fascinating question. As we establish these vast three-dimensional marine protected areas, how on earth do we monitor them? How do we ensure that a sanctuary on the high seas is actually respected? We cannot possibly build enough crewed ships to patrol the entirety of the global ocean. The answer, increasingly, lies in autonomous marine robotics. At Kalopa, we specialize in the 2.4 meter class of autonomous boats. To picture this, imagine a vessel roughly the length of a standard dining table. Now imagine placing that dining table in the middle of the North Atlantic Ocean, where the swells can routinely reach the height of a 2-story building, and the wind can howl with enough force to strip the crests off the waves. Yet, it is precisely this difficulty that makes the endeavour so worthwhile. Every failure teaches us something new about material science, about weather routing algorithms, about power management and mechanical resilience. The friendly rivalry of the Microtransat challenge pushes the entire industry forward. And why does this matter? Because the boats that can survive the Microtransat are the very same boats that will one day patrol the marine protected areas of the High Seas Treaty. They are the silent, tireless sentinels that will monitor the ocean's acoustic health, track the migration of the African penguin, and measure the temperature of the waters above the deep sea sponges of New Zealand. They are our eyes and ears in a realm where we cannot easily go. They are tools of conservation born from a deep, abiding respect for the maritime environment. As we look to the future, it is clear that the health of our oceans and the advancement of our technology are intrinsically linked. The challenges are vast, from political pushback on conservation zones to the sheer physical brutality of the marine environment. But the progress we are making, both in international law and in robotic engineering, gives us ample reason for hope. Thank you for spending this time with me today. It is a privilege to share these stories of the sea, of the creatures that call it home, and of the quiet, enduring machines we build to understand it better. If you have enjoyed our journey today, please consider subscribing to the Kalopa Mission Control Podcast on your favourite platform. Until next time, may the wind be fair and the seas be kind. Goodbye for now.